All right, in today's lesson, we're going to look at perpendicular bisectors and triangle. But first, we're going to review what a perpendicular bisector is. Remember, a perpendicular bisector divides a segment exactly in half at a 90-degree angle because it's going to bisect, so it divides it in half, and it's perpendicular, so it's at a 90-degree angle. So what it looks like when you see it on just a regular segment is you're going to see, if I have a segment, let's say it's got an A on one end and a B on the other end, okay? Then the perpendicular bisector has to go through it at a 90-degree angle, or sorry, out of the midpoint. First we're going to find the midpoint. So I'm going to have two equal sides on either side, and then it's going to come out from a 90-degree angle. And it's perpendicular and dividing this in half, so this green ray that I drew is my perpendicular bisector. So if I put a C for the midpoint here, and then just another point up here, D, we could say that ray CD is a perpendicular, upside down T for perpendicular, bisector of segment AB. Okay? And we're going to see if you draw a perpendicular bisector on all three sides of a triangle and draw them in, they're going to intersect at a single point, and that point is called the circumcenter, and we'll talk about in just a minute why we call that the circumcenter. But let's look at what happens when we do it in each of our different sizes of triangles. So remember, we've already looked at this now for 3 different times. We drew our altitudes in each triangle, and we saw that the intersection was the orthocenter. It's inside for an acute triangle. It's at the right angle on a right triangle, and it's outside the triangle on an obtuse triangle. Then we did our medians, and we found that they all intersected at the centroid, and it's the center is center of all the centers. It's the balancing point, and it's always, no matter the size of the triangle, always inside. Then we looked at our angle bisectors in the last lesson, and we said for our angle bisectors, they intersect at the incenter because it's the center of the circle that's inside the triangle. Okay, so let's go ahead and look at the perpendicular bisectors. I've already found my midpoints for 2 of my triangles. I still need to do it for the acute because I wanted to make sure that we knew what I meant when I was saying we're going to find the bisector. So I'm just going to zoom in to this acute triangle so we can find its midpoints, okay? Because that's the only way we can bisect it. So I'm going to start with the bottom, and I'm just going to measure it and see that it is 5.8 centimeters long. So I'm just going to divide that in half. 5.8 divided by 2 is 2.9. So my first point is going to be at 2.9. And it's a midpoint, so that means it's dividing this piece into 2 equal pieces, 2.9 and 2.9 centimeters. Okay, then I'm going to come over here and do the same thing for this segment. This segment is almost 4.2, 4.1, we could say 4.15 centimeters divided by 2 is 2.075, so just barely further than 2. Okay, so then these 2 pieces are the same. And then I have my last side, which when I measure that, it is about 6.2 centimeters. So that's going to be 3.1. 3.1 centimeters and 3.1 centimeters. And so these segments are the same. Okay, so now I need to draw a perpendicular. Remember, we did the same thing the other day. We found the medians, and then we went from the midpoint back to the corner. But now we want to make sure we leave the side straight, leaving it at a 90-degree angle. So here's how I'm going to get my 90-degree angle. I'm going to line my protractor up with the side, and I'm going to put that midpoint at the center of the protractor. I'm then going to mark 90 degrees and use that dot and my midpoint to line up to draw in my perpendicular bisector. Okay, so there's my perpendicular bisector of my first side. Okay, I'm going to do the same thing for the next side. Just going to line up with my midpoint. I'm going to mark my 90. I'm going to rotate and draw my ray, my perpendicular bisector. And then my last side, I'm going to line up and I'm going to find 90, make my dot and use that dot along with the midpoint to draw my perpendicular bisector in. So that's at 90. I should have marked this at 90. There we go. And I can see that they did intersect nicely right here. And we call that the circumcenter. We call that the circumcenter. And again, we're going to discuss here in just a little bit why we call it the circumcenter. Let's do the same thing with our right triangle and see where we get. We were inside for acute. Let's see where we end up for our right triangle. Okay, I'm going to start with my hypotenuse, lining up with the midpoint and the hypotenuse. I'm going to come up here and mark my 90. I'm going to use that dot along with the midpoint to line up and draw my perpendicular bisector. So it's perpendicular and it's bisecting. Now I'm going to do my longer leg of the two legs. I'm going to line up with my midpoint, make my mark at 90, and then use that mark and my midpoint to draw in my perpendicular bisector. So it's perpendicular, 90 degrees, and it's bisecting. Those are both equal. Okay, and my last one right here, I'm going to line up with my point and 90, and then I'm going to use that point for 90 along with the midpoint over here to line up and draw my perpendicular bisector. It is perpendicular and it's bisecting. Those two segments are equal. Okay, now let's look and see where they intersected. They intersected right here on the hypotenuse, at the midpoint of the hypotenuse. Okay, so in my right triangle, they're going to intersect right in the center, and on my right triangle, they're going to be on the hypotenuse at the midpoint. Let's look and see what happens on our obtuse triangle. So for my obtuse triangle, I'm going to do the same thing. I've already found my midpoints to save some time. I'm going to use my protractor, line up with the midpoint along the bottom, mark my 90-degree angle, use that mark along with the midpoint to sketch my line. It's 90 degrees, and that's a midpoint. Okay. Then I'm going to take my next midpoint right here. I'm going to line up with that side and that midpoint and make my 90 and use that midpoint and that 90 point to draw my angle bisector, or my perpendicular bisector. So it's perpendicular and it's bisecting. Okay, and then the last one over here, I'm going to line up with that midpoint and the side. I'm going to mark 90, and then I'm going to line up with that 90 mark and the midpoint. I made it a little low. That's okay. We're just sketching. It's perpendicular and these two are the same. So it looks like I don't have an intersection, but a perpendicular bisector doesn't have to just be a ray. I could take this perpendicular bisector and I can keep extending it back this direction. And notice I will still end up with a circumcenter. So I still end up with my circumcenter, which is right here. Okay? So when I look at all of these together, I can see that in an acute triangle, my circumcenter will be inside my triangle. In a right triangle, it's going to be at the midpoint of the hypotenuse, and on an obtuse triangle, it's going to be outside the triangle. And it's always going to be across from the longest side, outside the longest side. Okay? In the next video, we're going to look and see how we can identify and use our circumcenter and our perpendicular bisectors. Okay? Thank you so much for watching.